All right, so listen carefully. Last time we talked this to death. I swear, if it's not dead, maybe we'll back over it one more time with the truck, but it's pretty much dead. Okay? Y equals mx plus slope-intercept form. You can graph it frontwards and backwards. Pretty much everybody's on board with that, am I right? Yeah, pretty much there. Now today, we're going to also talk about what's called standard form. Now, geez, it's not hard. Now, why do we do that? Because it's standard. Whose bright idea was to make it standard? I don't know. I just played a game. Okay? Why does the football field have 100 yards? Because it looks stupid with 80 yards. I don't know. That's just how it is. I don't question it. We just play by the rules. So in a lot of countries, in a lot of different places, when we go to college, guys will write it this way as opposed to that way. I don't know why, they just do. So we're going to familiarize you with it. It's no big deal. What's the big difference between these two guys? Just looking at them. What? Well, besides the different letters part, that doesn't really bother me that much. But what's the big difference? There's two main differences. Yes? Yeah, look at it here. In standard form, x and y are on the same side. X and y on the same side. No big deal. So if it wasn't, we could move it. No, that's not so big a deal. Now there's two rules for standard form. There's two rules. And they're very straightforward rules. First of all, A is always non-negative. Does you mean positive, Mr. Groom? No, if I meant positive, I'd say positive. Darn it, I meant not negative. What number? What's a number that's not positive or negative? 0. So it's possible there could be no x's. Okay? But most of the time we're concerned with we want it to be positive. A, the number in front of x will be positive. Most of the time. Occasionally it'll be 0, and so it won't be there, and that's fine too. Okay? Do we care about B? We couldn't give a rat's patootie about B. We care that A, the number in front of x, is positive. That's just the rules. I don't know why. That's how it is. Okay? Secondly, and this is the biggie, is this. No fractions allowed. How many of you are fractophobes? Good. Lovely. So we're going to lose them. Okay? They're gone. Right? Again, why? Oh no, it's just out of the rules. So, we're going to go from one form to the other and back and forth and back and have some fun with it. So, for instance, suppose we have this guy. Could we put him in standard form? Huh? Well, now, there's no rhyme or reason what order we do it in. I could care less how you do it. But the first thing, there's two rules. One says x and y have to be on the same side. And the other rule says no fractions allowed, right? So, Tyler's right. We could lose the fraction right now if you like. How would we lose the fraction? We will times by the common denominator. For the love of George, if you make it a decimal, you still got a fraction. Because what is a fraction? A decimal is a 4-man's fraction. That's all it is. When you say 6/100ths, what do you really mean? You mean 6 over 100. It's still a fraction. So, what happens when I multiply here? If I times everybody by 3, what happens? I get 3y is equal to 2x plus 5. Is that right? I don't multiply well. Fortunately, it's not a prerequisite for this job. There it is. Now, no fractions. Sweet. Are x and y on the same side yet, Maggie? Are x and y on the same side yet? I was waiting for you to tell me I got the wrong name. Huh? No. Let's fix that, shall we? Now, how are you going to do it? Are you going to move the y over there with the x? Or are you going to move the x over with the y? Okay, how are you going to move this x over here, dear? Alrighty. And so now I have negative 2x plus 3y equals 15. Just a minute, one thing at a time. That's beautiful, by the way. And then you were going to say?
You can multiply by 1, this whole equation on both sides, so you have...
Negative 1?
Yeah, negative 1 on both sides.
Right. So she's going to time everybody by negative 1, which makes it 2x. Nice. Equals negative 15. Nice. And you're done. Sweet. Always more than one way to skin a cat. So it's not personally how I'd have got it. Okay? Me personally, right off the bat, I probably have done this. I might have subtracted 2/3 x to both sides. You with me on that? And then I would have multiplied not by 3 over 1, I would have multiplied by negative 3 over 1. Oh, it's the same thing. Others of you, Roden, might have said, I like this idea that I multiply by 3 first. So Roten does this. She has this on her paper. Remember, it takes all kinds to make the world go around. Now watch Roten here. Watch her. Watch her do this. I'm going to play musical chairs with the 15 and the 3y. If I'm going to move this 15 over here, what's it going to become? Negative, right? If she moves this 3y over here, what's it going to become? Negative. And we all get to the same answer. And Mr. Groom couldn't care less. Couldn't care about it. Just get there. Okay? Lots of ways to get there. As long as you end up with 2x minus 3y equals negative 15, we are home free. You hear that, Paulson? It's Paulson? Is it Paulson? It's Olivia. Good for me. Good for me. All right, next. Check this out. Now, how do we graph? How do we graph from this format? Now, quite frankly, if you asked me, Mr. Groom, would you prefer to graph from standard form, or would you prefer to graph from slope-intercept form? I actually prefer this form better. And I'll show you why. Okay. We use what's called the intercept method. I personally call it the palm method myself. Envision this. Envision you're going shopping. You're going to buy either food for your kids, and I mean food, I mean just like some burritos. Good for you, Shelby Wacker. Or you're going to buy cigarettes. Good for you. Okay, great. Not both. It's an either or thing. You get $50 because you're going to buy a whole carton or something. Good for you. Lovely. Okay? Carton of cigarettes, $50. Good for her. She's got $50 burning a hole in her pocket. Or she's going to buy some burritos. She could buy 10 packages of burritos. Sweet. Now, by saying that, I'm assuming that she's going to buy all of one or all of the other, right? So if burritos are $5 a package, how many could she buy for $10? 10 of them, right? Because 5 goes into 50 10 times. Is that true? Mm-hmm. We are assuming she's buying how many cigarettes? No. She had $50. She didn't spend any money on cigarettes. She spent it all on the burritos. How many cigarettes is that? 0. They went away. It's gone. Okay? What if she says, no, darn it, I have to have my cigarettes. Kids, the kids be danged. I buy 0 burritos. $50 for a carton of cigarettes. She spends the entire $50 on that. So how many cigarettes did she buy? 1 carton of them. That's a lot of cigarettes, but 1 carton of them. And she bought how many packages of burritos? 0. Now, this is how we do this thing. Okay? This is Mr. Groom's method. It only works very well on the board. You guys will have to just play along on your paper. I write a big fatty 0 in my poem. Okay? Now, let's suppose I let x equal 0. What happens? 2 times 0 is? 0. Now, is there anyone who cannot solve that little algebra problem right there? Because if there is, there's the door. You might want to go away. Look at this problem. What is 2 times 0? It's 0. Solve that problem for me right there. What do you get? Y equals 5. You with me on that? Yep. Now, that is, what intercept is that? Is that the y-intercept or the x-intercept? Y. The y-intercept. And I play the same game. Oh, let y be 0. What's x? Negative 7.5. Who said that? Who said negative 7.5? You did? Which is Olivia. Is that right? Don't know the last name. Sorensen. Nice job, Sorensen. Because you did negative 15 divided by 2. 6.5. And she got negative 7.5. Did everyone see that? Do you or not? Don't lie to me. You got it? Okay, cool.
You don't have to worry about slopes.
There it is. You're done. Now, what was the problem we had a minute ago? The original problem was y equals 2/3 x plus 5. Is that true?
Yeah.
Okay. What would happen if we graphed this thing? It better be the same thing. What's the y-intercept here? 1, 2, 3, 4. Oh, wait, it's 5. How about that? How about that? The slope is 2/3. Up 2 over 1, 2, 3. And lo and behold, where are we? On the same line. So it doesn't make any difference, right? Does it matter if you're wearing your black jersey or your white jersey? Not so much. I mean, maybe the black one looks better, maybe the white one looks better. But it's you. It's you. It doesn't make any difference. Okay? It doesn't matter. One line or the other form, it doesn't make any difference. How many different ways did we have this written? Check this out. How many different ways did we have the same function written? We had this one. We had this way. We had that way. This way. There's a zillion ways to write it. Is it all the same function? Yeah. Okay? So, when we graph these guys, we're going to graph them today. We're going to practice from what's called the intercept method. A little bit of this. And we're going to go back and forth between slope-intercept form and standard form to slope-intercept form. We're going to play a little of both because you need to be comfortable with it. Okay? So, let's try one from the top. Nice, easy one. Get her started here.
Sweet.
It's a negative 10. All right. So, right off the top, you set this up for me here. What is your name? Oh, thanks. What?
Prairie.
All right, Prairie, help me set it up. The whole thing, yep, from the top. Had a kid. Nice. Darn it, I'm getting ahead of you. I thought you were going to keep going. All right, then what? 4 minus a minus 10 is? Positive what? Atta girl. Nice. 3 minus 10? Negative. Yeah, good. Don't think about it too long. Good. Divide. So m is equal to? Negative 2. Nice. The 2. In case you're wondering. Negative 2. Yeah.
So at this point, do you plug in like 3 and 10 to that equation?
So you plug in negative 2 to one of those two equations. Right? So 3 times negative 2 plus b. Right? This is all review from last time. Nothing new, right? Nothing new. So that's 6. Minus 6. Minus 6. So b is equal to negative 2. Did I screw something up?
Yeah, because 3 times negative 2 is going to be negative 6, so you're going to add 6 to both sides and you're going to get 10 equals b.
Okay. If I turn red when I made a mistake, that's what I look like. Nice. Good. So y is equal to what? My final answer is y equals? Negative 2 x plus 10. Slope-intercept form. Standard form will look like what then? Standard form, how do I get it over there?
2x plus
Add 2x to both sides.
plus y
So I get 2x plus y equals 10. Done. Done. Well, I'm going to graph it in a jiffy. You okay with that, Beavers? You find that? Seriously? Okay. Okay. Now, great. So, if I graphed it from either one, I get the same answer. But let's check it out. Let's use the old palm method here. If I cover up the x's, what's y equal to? 10. X is 0. Y is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Cover up the y's. That means 2x is equal to 10. Which means x is equal to 5. Does this thing have a negative slope? Is that good? Well, it shouldn't have a negative slope because it had a slope of negative 2. What you will find, Ms. Hood, is that when you're playing these little games, that you'll find that this thing right here, this sign, this plus right here, it's going to be the opposite of whatever your slope is. Kind of cool. If it's a minus, that means you had a positive slope. That's what it'll always end up being like that. Okay? That's a little tip for you. If you had like, on the original problem there, it was y equals 2x plus 10.
So y equals 2x.
I was saying if it was y equals 2, if it was y equals 2x plus 10.
Okay.
When you put it in standard form, you're going to end up with 2x minus y.
What's minus y?
It's going to be opposite. It's going to be the opposite sign.
Multiply the y by the negative 4.
But
On the x limit at 5 instead of 2.
good question. Here it is again. Okay, if y equals 0, boom, then 2x is equal to 10. So that means 1x is equal to 5. So you end up with this cute little equation. 2x equals 10, x is equal to 5. Why is this true? This is true when y is equal to 0. What is this point right here? This is the point 5, comma 0.
So you're doing the same.
Why is this y equals 10? It's 10, but it's something comma 10. What is it? It's 0, comma 10. So y-intercepts and the x-intercept, called the intercept method. Okay, I like the palm method. Doesn't really work on your paper though, right? It works better with your finger or with a pencil. Think about it. Cover it up with your palm. What happens? You cover up your whole paper. Seriously. Oh, yeah, I don't know. I can't read the dumb problem anymore. It doesn't work well on your paper. Okay? All right. Now, suppose you had it in this format. Oh, first of all, let's freak everybody out. Oh my gosh! Oh, it's so horrible, Mr. Groom. It's so awful. No big deal. No big panic. Nobody panic. Everything will be just fine. Should we graph this, please, just like it stands? What do we get? Cover up the y's if you want. So x is 2. Cover up the x's and y is 6 seconds. Yeah, it wasn't very hard, was it? So about there, right? I'm done. Again, I got a little lazy just then. We need to make sure we label our graphs. There. Tish, what if I wanted to convert this to slope-intercept form? Then I would need to get it in this format. Move the y's. Well, I would just move the x. Something I hate doing, if you know anything about Mr. Groom, when you get to learn something about Mr. Groom, one thing I hate doing is more work than I have to do. Oh, I hate it. Seriously. I don't mind working if I have to do it, but if it's something I don't have to do, I'm not particularly in good humor about doing it. So what would be easier? Just moving the x's or moving the y's and then moving the cover back over here? What would be easier? Just the x. So I'm going to move this to 3x over there. We're going to subtract it. So now I have 7y is equal to negative 3x plus 6. Since it's 1y here, I'd like it to be 1y over there, so I'm going to divide by 7. Divide by 7. And so I get y is equal to negative 3/7 x plus 6/7. Does this look familiar, the 6/7 business? It should be. That's the y-intercept. It's already on the graph. It's handy. The slope is negative 3/7. Down 3 over 7. Guess what? You end up back on the line again. So I neglected to mention the other day. I mentioned slope-intercept form, but we didn't do a lot with it. We certainly didn't graph from it. That should give you a little bit of enough to play with tonight when we go home. You know? Questions about those guys at all?
Is this 1.2 or 1.3?
It's the end of 1.3 that I didn't mention the other day. I'm sorry. Well, it's part of 1.3. It's the end of 1.2, first part of 1.3. But we're going to go further today. Now, today we are going to talk about parallel. Why does that look funny? Why does that look funny? Boy, that's pretty bad. It's right. It just looks funny. Parallel and perpendicular lines. What do we know about perpendicular and parallel lines?
Parallel lines and then perpendicular lines.
Oh, cool. In regards to slopes, what do we know about them? Yes.
A parallel line will have the same slope, and then the perpendicular will have an exact opposite slope. Like,
That meaning what?
meaning that like if you have your slope is 3, then it's gonna be negative 1/3.
Okay, we'll talk about that more. That's perfect, actually. Can I just say that when you look over your glasses at me like that, it reminds me of this teacher I had in high school, Mr. Frank DeAndrew, who would stand up on the podium, and he would read like this, and he'd just look up, he'd look over the top of his, proving me over the top of his glasses at you. I've never met a young person that wear glasses. Cool. Reminds me of him. Not fondly, I don't remember him fondly, all he did is yell at us. But that's probably because he taught junior high. Who would teach junior high? They didn't have to. Some people like it. Good for them. It scares me. Junior hires. If I had to teach junior hires all the time, middle school, whatever, good for you. That makes sense. I could see you teaching middle school, junior high. Yeah, I totally could. I know, I totally could. If I had to, the choice between that and shoveling manure, give me the shovel, baby. Let's start shoveling. Seriously, I can't handle them. They're all over the place. Ask random questions. Couldn't do it, beavers. All right, so parallel lines. Listen carefully. They have the same slope, yes? That's big. And that makes sense because here's a line. If I want to be parallel to it, it'll have to have the same slope as him. Will it have the same y-intercept as him? No, because if it had the same intercept, it'd be the same line, right? So, parallel lines have the same slope, which forces the opinion that Tyler's had they do not cross each other. That's sweet. Because every time this one goes up 2 and over 1, this one goes up 2 and over 1. It'll never catch up. It's kind of like, okay, I just flew past the cop doing 80 miles an hour. So he pulls out and starts chasing me 80 miles an hour. I'm safe, dude. I'm safe. He can't catch me, right? Of course he won't. He'll go 115 and catch me. He'll go ahead. But he personally can't catch me if we're going the same speed. We have the same slope. He will not catch me. Now what we're going to do with that today is this. I will say something like this. Find the equation of the line parallel to 3x plus 2y passing through 6, 9. Phew.
What?
Again, slow down, Mr. Green. You're going too fast. This is what it looks like. Here is 3x plus 2y equals 10. Sorry, my bad. Here is some line. I don't know where it is. Don't really care. There's some line. Okay? I want a line that is parallel to it that passes through the number 6, 9. So I want this guy. And I don't want a picture of it. I want an equation for it. I want y equals mx plus b. Okay? That's what the question's asking. Okay? Now, I don't know if that's what this line, actually I know this line does not look like that. But in essence, what we need to know is this. This line right here is going to tell us our what? Our slope. And then we're home free. Okay? So one thing at a time. If I'm going to be parallel to it, I need to know what I'm going to be parallel to. This line. Okay? So it goes like this today. Oops. On this particular problem, it would look like the following. Okay, how do I find the slope of this equation right here? Well, it would be helpful if it was not in standard form. It would be helpful if it was in slope-intercept form. So it's going to be 2y is equal to negative 3x plus 10. Does everyone buy that? Yes. Minus 3x to both sides. And then what? Divide by 2. Now, what is the slope then that we're interested in? Negative 3 halves. Mr. Groom, what about this 5? What about the y-intercept? We don't care. Thank you. Can you say that louder, Olivia? Not only do we not care, you know what, it used to bother me. When I say, people would say, like, I could care less. No, we couldn't care less if we tried. No, we don't care about it.
We've been going on for a while.
Sweet. So, what we actually need to do, though, is use this point up here, 6, 9, and we need to find the equation of a line like this. Okay? Because we have this piece right here, right? Yes. So what are we going to do? Yeah, just plug it in. Plug it in. And what is 3 halves, negative 3 halves, times 6? Why, it's negative 9. Of course. Silly. Oh, come on. 6 over 1. It's negative 18 divided by 2, negative 9. Or calculator it up. So I plus 9. Right, Kevin? Plus 9. So b is equal to 18. So my equation is y equals negative 3 halves x plus 18.
So that's all you wanted from that very beginning question was that, right at the end?
Yeah. Unless, put your glasses back on. Now, what if I said, darn it, you know what, I can't. What if I wanted it in slope-intercept form instead? I mean, not slope-intercept, I mean standard form. No, I still would have done everything the same. If I wanted this baby in standard form, nothing changes till right here, right? And then what do I have to do? I need to put it back in its standard form. So I'm going to add 3 halves to both sides. So I get 3 halves x plus y equals 18. A is positive. That's cool. Oh my gosh, there's a fraction. So we're going to times everybody by 2, right? Times everybody by 2. Times everybody by 2. What does that give us here? These cancel. The 2's cancel here. I get 3x plus 2y equals 6. Or calculator it up if you like. That's great. Yeah, exactly. That's what we wanted from the get-go. Have to tell you the line so we know what we're going to be parallel to. Okay, I have to tell you a point so I know where we're going. Okay? And then, of course, really either here or here, depending on what the book asks for. Do they ask for it in slope-intercept form? Do they ask for it in standard form? And on the test, I may really ask for both ways. I don't know. I'm excited yet. Anyone else need to talk to that? We good? Alright? Alright, so another one. Alright, so again, find the equation of the line parallel to 2x plus 5y equals 9, passing through ten zero. That's handy. I like that. All right. So needs to be in slope-intercept form, yes? First. So it's going to look like what? 5y is equal to what?
2x, -2x.
Negative 2x, right? Because we're going to subtract it over the other side.
Plus 9.
Plus 9. Roden, I'm going to tell you a little secret. Don't tell anyone I told you this. It's our little secret, Roden. Check it out. If I move the 2x over to the other side, what has to happen to its sign? How do I get it from over here to over there? I'm going to minus it every time, right? I'm going to change the sign. Okay? So whatever the sign was over here, I move to the other side, it becomes the opposite sign, right? Sweet, that's all there's to it. That's it, you're done. And then I need to divide by 5. It's our little secret. Don't tell anyone, all right?
Okay.
All right. So y is equal to negative 2/5 x plus 9/5. This right here, I could care less about. Yes? Shoot, it's gone. Couldn't care less about him.
90.
All I want is the slope. So y equals what? Negative 2/5. Oh, I'm gonna write. Yes, you're right. Whoever said that. You're right. Who said that? Oh, nice job, Cassidy. 0 is equal to. Quick, what's negative 2/5 times 10?
0.
Negative. Alright? Plus 4. So 4 is equal to b. We're home free out, yes? So then I go y is equal to what? What's the equation of my line then? Negative 2/5 x plus 4. Oh, hey, back to that last problem for a second. Did we notice that at the end of that last problem, 3x plus 2y, da 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 da? What did it look like previously? Oh my gosh, 3x plus 2y. How cool is that? All right. Next. Cool. When I get back, guess what it's going to look like in a minute? It's going to look like 2x plus 5y, doesn't it?
Yeah.
They better look the same. How do I move this back over there if I want it in standard form? I add the 2/5. I just move it over here, change sign, right? So 2/5 x plus y equals 4. Who am I going to times by?
2.
5. Count them, not the 0. 5. That's right. So that's going to give me what? If I times by 5, it's going to give me? Yay!
So that's
That's it. That's your answer, lady. It's your answer in what form? Standard form. Good, you should. All right, now. All right, so perpendicular lines. Listen carefully. Have negative reciprocal slopes. So, what does that mean? It means that if this one is m is equal to 2/5, let's just say, then the perpendicular one would be m is equal to negative 5/2. So we flip it and we switch it. Very easy. Flip and switch. Obviously, if you're going to be perpendicular, if this one's going up, the other one has to be coming down. So they can't have the same sign, obviously. Is that true for everybody? Everybody understands that? So if they're going to be perpendicular, if one's going up, the other one has to be coming down. If this one's going up 5 and over 2, this one has to be going down 2 and over 5. completely opposite of each other. Okay? Well said. The other thing is this. Notice that when you multiply them, 2/5 in this case times negative 5/2, what do you get? Negative 1. The product of their slopes is negative 1. In case you need to check yourself. You can't just flip and switch. If that's too hard for you, then you can check it this way, see if in fact it does come out to be negative 1 when you multiply them. Okay? So, Mr. Groom, so what are we going to do with that? Well, it's going to be the same thing. Find the equation of the line, but not parallel this time. Perpendicular to x plus 5y equals 9, passing through. There's an R there somewhere, okay? Passing through 2, 1. Cool. What? Huh? Alright. Now, again, gotta have it in slope-intercept form right off the bat, yes? What's your name? Tia. Help me out. Help me get it in slope-intercept form, would you please? Go ahead. Come on, Tia. Move the x. How am I going to move it? Good. So I'm going to go 5y is equal to negative x plus 9. Good. Very nice. And then what? This is 5 times y. They're divided by 5. Good for you. So now I have y is equal to, what's my slope here? What number's in front of x?
1.
Negative 1/5, right? Is that true? Can everyone see that? It's negative 1/5 is the actual number there. Plus 9/5. Now what about this 9/5? Could care less. Okay? All I want is what I want. Right? I want the slope. Give it to me. Now, I don't want parallel lines, because if I wanted parallel lines, I'd take the negative 1/5. So Monique, I want perpendicular lines. Let's flip it, switch it, girl. What's it going to be?
Negative 5.
Now, if I switch the sign of a negative, it becomes a
Positive.
So I flip it and switch it, it becomes a positive 5, right? Flip it and switch it, right? Okay, good. So then it's going to be y is equal to 5x plus b, is that right? And I conveniently have a 1 and a 2 here, so let's plug them in. I gotta be honest, it feels like lunchtime right now. Minus 10, minus 10. So b is equal to negative 9. Do you agree? Wait. Okay, Elise is going to double check me. Am I right? Olivia Sorensen, am I right? Well, Olivia's right. Olivia says I'm right, so I feel good. So then my answer is y equals 5x minus 9. That's the perpendicular line in slope-intercept form. Okay? Okay, before you leave, check this out. Check this out. Watch me do this. Watch this next part. Just watch carefully. Watch me play musical chairs. The 9's going to go over here. The y is going to come over here, and I'm going to get 5x minus y equals 9. Stop. Wait. Look. Wait for it. Wait for it. Here's the original problem was x plus 5y. Now it is 5x minus y. Completely off. All right, go away. Have a nice day, people.